Hey everybody, so this video is going to talk about exponential regression. So we did regression in our previous unit when we talked about the line of best fit or the curve of best fit. Well, just like those different kinds of equations, we can also do it with exponential functions. Just as a reminder, the form of an exponential function is y equals a times b to the power of x, where y and x are our variables and a and b are going to be numbers of some kind. So when we type this onto Desmos, we are going to type y1, and don't forget about the 1. We always want to include the 1. And then our squiggle, a b to the power of x1. And the way that you get a power, just like you did on for the curve of best fit, is you could always press shift and then 6 to get like the little hat above the 6. That's going to make it an exponent. So just a couple of other notes as well is that we talked about in the previous lesson about increasing and decreasing exponential functions. So when we have a function that is decreasing, that is going to be called decay. So it's going to be decaying, it's going to be going down. And if something is growing, we're going to call that an exponential growth function. So again, decaying functions are when my b value is between 0 and 1, and growth functions are when my b value is greater than 1. So we are going to not worry about any of this. This is all the TI-83, but just so that you know, the same steps that we did for the regression for the line of best fit and curve of best fit, those are still going to be the same. We still have to enter a table of values and then type this equation on another line, and it's going to give us our a and b values. So we have one example that we are going to go through, just the one example today. This one is talking about a freshly brewed cup of coffee, and they monitor the temperature after a certain amount of minutes. So part A says determine the equation of the exponential regression function. So what I'm going to do is I'm going to switch over to Desmos. And again, to add a table, you just click the plus at the top left and then table. It brings up an x1 and y1. Again, that is why we type those in our regression equation. So I'm going to enter the x values first: 11, 15, 18, 22, 25, 30, 34, 38, 42, 45, and 50. So those are the amount of minutes where they are tracking the temperature. And then my y values, those are the temperatures. So 168.7, 158.1, 149.2, 141.7, 134.6. And just as we are entering this data in here, just try to think about, do you think that this is a growth function or a decay function, and why do you think that will be? We're going to find out in a minute when we actually do our regression equation. We're going to actually take a look at where the dots are located on our graph, which will be a good indication of the shape of our function. Okay, so we can't see anything in our window right now because we're only going from -10 to 10 for our x values and only from like -6 to 6 for our y values. So again, if you want to adjust the window, click on the wrench at the top right, and you can change the labels for the x and the y axis. So for the x-axis, I'm going to go, let's say, -2 up to 60, because my x values are between 0 and 50. And my y values, let's go from, well, my lowest is 100. So maybe we'll put 100 on there. Actually, let's put 90, get maybe a little better window there, up to 180. And now we can see where all of our points are, and they are going downwards. So this is an exponential decay function. Okay, so we've got our table of values there. Now on another line, we're going to type y1 and then squiggle a b to the power of x1. And we get this graph right here. Okay, so when we scroll down, we can see what our A and our B values are. So when we go to write the equation, and I'll switch back to the notes in a moment, but we're going to write y equals my A value, 174.05, again, round it to 2 decimal places. And then my B number goes in brackets, so 0.99 to the power of x. So I'm going to switch back here to the video, and we've got that written down here. So y equals 174.05 times 0.99 to the power of x. Part B says, is it exponential growth or exponential decay, and why? So we've already just talked about this a little bit. It is decay, and the reason, I mean, you can give whatever reason for a decay that you want. I'm going to use a mathematical reason, because 0 is less than b is less than 1. Okay, so my b value, 0.99, is between 0 and 1. Part C says, what is the y-intercept of the exponential regression? So again, on Desmos, we can just go ahead and click on that point, which is right there. And my y-intercept is y equals 174.05. Again, with an exponential function, the y-intercept is always the a value. So I'm going to write that in brackets here. And again, I'll switch back to the notes in a little bit. Okay, part D says, using your exponential regression, when is the temperature of the coffee 106 degrees? So because we are talking about, we're given the temperature number, temperature is my y values. So on a new line, I'm going to write y equals 106. And we're going to find what the x value is just by clicking on that intersection point. So when is the temperature 106 degrees? It's going to be after 39.70 minutes. Okay, I'm going to switch back here to the notes just so that you can take a look. So again, I've got my y-intercept is y equals 174.05, which is my a value. And it is 106 degrees after 39.70 minutes. So we are going to do E, F, and G, and then I will switch back to the notes one more time. So my E question says, what is the predicted temperature of the coffee after 1 hour? So now it's giving us time. So 1 hour is 60 minutes. Again, my time is measured in minutes. So I'm going to enter in x is equal to 60 and see what the intersection point is. Now we're going to have to move our graph around because we didn't, when we adjusted our window, we didn't leave room for x is equal to 60. So when we click on that intersection point, the predicted temperature would be 82.26 degrees Fahrenheit. And again, we're not just interested in what the number is, you have to also include the units of whatever it is that the question is asking you. Part F says, if restaurants want to serve the coffee at 155 degrees, so that's a Y number, how long should they wait before serving the coffee? So let's enter in Y is equal to 155 and look for that intersection point is right there. And we can see that the x value is 9.28, so they should wait 9.28 minutes. And then part G says, if the temperature in the room is 76 degrees, at what time will the coffee stop cooling? So again, we are given a temperature number of 76. So we are going to enter y is equal to 76. And there is the intersection point right there at 66.33 minutes. So I'm going to switch back to my notes one final time here. And so we have, after 1 hour, or where x equals 60, the temperature is 82.26 degrees Fahrenheit. At the temperature of 155 degrees, the amount of time that it takes to reach that is 9.28 minutes. And for 76 degrees, the time is 66.33 minutes. So again, make sure that you are If the question is asking you for something in context, make sure that you give the context in your answer. So in this case, it is temperature and number of minutes. And that's pretty much all there is for exponential regression. So enter your table of values. Don't forget your y1 abx1 equation, and then just make sure that you feel comfortable answering the follow-up questions.